Hey there, asteroid enthusiasts. Today, we're going to take a closer look at the asteroids that we really need to worry about. But don't worry, this isn't a doom and gloom video. We'll explore some cool facts and learn about some out-of-this-world solutions to the asteroid problem. Did you know that asteroids are remnants from the formation of our solar system? They are essentially space rocks that are hurtling through space, sometimes coming dangerously close to Earth. While most of these rocks pose no threat to us, there are a few that could potentially cause massive destruction. And that's what we're here to talk about today. We'll be looking at the characteristics of the asteroids that pose the greatest risk and discussing some of the wild strategies scientists have come up with to deflect or destroy them. From nuclear bombs to giant space magnets, we'll explore all the possibilities. So buckle up and get ready for an asteroid adventure. What are asteroids? Asteroids are small, rocky objects that orbit the Sun. They are sometimes referred to as minor planets or planetoids, and they can range in size from a few meters to several hundred kilometers. Most asteroids in our solar system are located in the asteroid belt between Mars and Jupiter, but some asteroids also have orbits that cross Earth's path. Asteroids are classified based on their composition and physical properties. There are three main types of asteroids: C-type, S-type, and M-type. C-type asteroids are the most common and are made up of carbon-based materials. S-type asteroids are composed of silicate materials and are brighter than C-type asteroids. M-type asteroids are metallic and are the least common type. The composition of asteroids can vary depending on their type and location. Some asteroids contain valuable minerals such as iron, nickel, and platinum, while others are composed of rock and dust. Some asteroids are also known to contain water and other volatiles. Asteroids are classified based on their orbit and size. The most commonly used classification system is the Torino scale, which rates the impact risk of asteroids on a scale from 0 to 10. A rating of 0 indicates that the asteroid poses no risk, while a rating of 10 means that the impact is inevitable and will cause a global catastrophe. The potential impact of asteroids. Asteroid impacts have the potential to cause catastrophic damage to our planet. Scientists believe that Earth has experienced several asteroid impacts throughout its history, the most famous being the one that wiped out the dinosaurs 66 million years ago. While catastrophic asteroid impacts are rare, the consequences can be devastating. If an asteroid were to impact Earth, the consequences would depend on several factors, including the size and composition of the asteroid and the location of impact. However, an asteroid impact could cause widespread destruction, including tsunamis, earthquakes, wildfires, and dust storms. It could also lead to a global cooling effect by blocking out the sun's rays and causing a nuclear winter effect. Historical records indicate that Earth has experienced several asteroid impacts in the past. One of the most well-known examples is the Chicxulub impact, which occurred 66 million years ago and is believed to have caused the extinction of the dinosaurs. Another example is the Tunguska event, which occurred in 1908 in Russia and caused an explosion equivalent to 10 to 15 megatons of TNT. These historical examples remind us of the potential danger that asteroids pose to our planet. However, technological advances have allowed us to detect and track asteroids more accurately than ever before, allowing us to prepare and mitigate the potential impact of these celestial objects. In the next section, we'll explore some methods scientists use to detect and track asteroids. Asteroid detection. Detecting asteroids and predicting their paths is crucial for mitigating their potential impact on Earth. Scientists use several methods to detect and track asteroids, including ground-based telescopes are the most commonly used tools for asteroid detection. Ground-based telescopes can detect asteroids by measuring their reflected sunlight and their movement across the sky. The data collected by these telescopes can be used to determine the asteroid's size, composition, and trajectory. Space-based telescopes. These are launched into space and can detect asteroids from outside Earth's atmosphere. Space-based telescopes can provide more accurate data on an asteroid's trajectory and composition than ground-based telescopes. Radar. Radar can detect asteroids by bouncing radio waves off their surface. This method can provide more accurate data on an asteroid's size and shape than telescopes. Infrared detection. Infrared telescopes can detect the heat emitted by asteroids, allowing scientists to determine their composition and size. Once an asteroid is detected, scientists use computer models to predict its path and determine the likelihood of an impact on Earth. If an asteroid is found to be on a collision course with Earth, scientists can develop strategies to deflect or destroy the asteroid before it reaches our planet. Detecting and tracking asteroids is crucial for protecting our planet from potential impacts. Advances in technology and increased funding for asteroid detection programs have significantly improved our ability to detect and track these celestial objects, providing greater safety for life on Earth. Top asteroids to worry about. While there are many asteroids in our solar system, not all of them pose a significant threat to Earth. However, some asteroids have been identified as potentially hazardous due to their size, trajectory, and composition. In this section, we'll take a look at 3 of the top asteroids to worry about. One of the most well-known potentially hazardous asteroids is Apophis, named after the Egyptian god of chaos. Apophis is estimated to be approximately 370 meters in diameter and can impact Earth in 2060. While the probability of impact is currently very low, it is still considered a potential threat and is closely monitored by scientists. Another potentially hazardous asteroid is Bennu, which is currently being studied by NASA's OSIRIS-REx mission. Bennu is approximately 500 meters in diameter and has a chance of impacting Earth in the late 22nd century. The OSIRIS-REx mission is designed to collect a sample of Bennu's surface material and return it to Earth for study, which will help scientists better understand the asteroid's composition and trajectory. The third potentially hazardous asteroid on our list is the 2009 FD, which was discovered in 2009 and has a chance of impacting Earth in 2185. 2009 FD is estimated to be approximately 220 meters in diameter and is classified as a near-Earth object, meaning it has the potential to come within 0.5 astronomical units, approximately 7.5 million kilometers of Earth's orbit. In addition to these 3 asteroids, several other potentially hazardous asteroids are closely monitored by scientists. By tracking their paths and developing strategies to deflect or destroy them, if necessary, we can help protect our planet from the potential threat of asteroid impacts. Mitigation strategies. While the probability of a catastrophic asteroid impact is low, the potential consequences make developing strategies to mitigate the risk essential. There are several techniques that scientists have proposed for deflecting or destroying an incoming asteroid. One method involves using a spacecraft to alter the asteroid's trajectory through a gravitational tug or kinetic impact. Another approach is to use a nuclear explosive device to break up the asteroid into smaller, more manageable pieces. However, the use of nuclear weapons is highly controversial and is only considered a last resort. Scientists are also exploring the potential of using solar sails, laser ablation, and other emerging technologies for asteroid deflection. Another potential mitigation strategy is to use a gravity tractor, which involves using the gravitational attraction of a spacecraft to slowly alter the asteroid's trajectory over a long time. This technique would require a spacecraft to rendezvous with the asteroid and maintain close proximity to it for a period of several years to gradually nudge it off course. While this method is less destructive than using a kinetic impactor or nuclear explosive device, it requires a longer lead time and a greater level of precision in controlling the spacecraft's trajectory. Overall, scientists believe that a combination of these different mitigation strategies may be needed to address the full range of potential asteroid threats. Characteristics of dangerous asteroids. Not all asteroids are created equal regarding their potential threat to Earth. Several characteristics make an asteroid more dangerous, including its size, composition, and trajectory. Larger asteroids have more mass and kinetic energy, which means they would cause more damage upon impact. Asteroids composed of denser materials like iron and nickel would also cause more damage than lighter material. The trajectory of an asteroid is also a critical factor, as some asteroids have orbits that cross Earth's orbit, which increases the likelihood of an impact. Additionally, the angle of approach and velocity of the asteroid can affect the amount of damage it causes upon impact. By studying the characteristics of dangerous asteroids, scientists can better understand the potential threats they pose and develop strategies to mitigate the risk. That's all for today's video on the top asteroids to worry about. I hope you found this information useful and insightful. If you enjoyed the video, please give it a thumbs up and consider subscribing to our channel for fascinating content about space and science.